Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Inshallah, we're going to talk today about chapter 10, which is further differentiation. So, basically, in this chapter, we have only two topics. The first one, which is 10.1, is implicit functions, and the other one is connected rates of change, so which is basically based on that we're going to do today. First of all, you have to understand what do we mean by the implicit functions. Basically, implicit functions is one of the types of the functions. So basically, we can express the functions or divide them into two types. So we can classify them into two types. The first type, which is explicit functions, and the other one is implicit functions. Explicit, implicit, explicit, and implicit. Explicit, as you see, if y is given in terms of x, y is given in terms of x, so we call that explicit. For example, I'll give an example of the explicit, which is 1 plus 2 sine x. So the clear example of explicit function, when you have y as the subject and x as the variable, maybe x is subject and y is the variable as well, so we can call that as explicit function. Implicit is the opposite directly. So if y and x are given without knowing which one in terms of the other, so we couldn't state which one is the subject and which one is the variable. For example, x squared plus 2y is equal to 3, so we call that implicit function. So basically, in the previous chapter and even in semester 1, we did all the rules of differentiation on explicit function when you have y in terms of x. Even last chapter 5. But here in this chapter, we're going to work only in implicit functions. So that's why this topic is talking about only implicit functions. And of course, the differentiation, the type of differentiation that we're going to use with this type of function, we called it implicit differentiation. For example, in exercise 10a into page 208 and we'll tell 210, we start with question number 1. I prefer, guys, whenever we start in doing any one of the questions on the exercise, I prefer to keep the textbook beside you. Question number 1c, d by dx of 3y power 4. Yes, so as you see now, you don't have any x, and we have to differentiate respecting to x. All the times of differentiation, it's supposed to be respecting to x. So what we have to do here, we do normal differentiation, so we just multiply 4 the power times 3, which is the coefficient of the variable. So 4 times 3 is equal to 12. So 12. Then reduce the power by 1, as we did normally with the x. But the point is here, you have to add one more term because you differentiate respecting to x. But what do you have now? You have y. So you're supposed to write y dash, or you can write 12y cubed dy by dx. Both of them are the same. So y dash or y prime or dy by dx. Let's apply the same thing here. Remember, in chapter 5, I told you if you multiply two different functions, we call that product rule. So you have to use product rule. First one is u and the other one is v. U is x squared and v is y squared. Sorry, it's not x squared, it's just x. Yes, and differentiation of u is 1. Differentiation of v prime is 2y, y dash. 2y times y dash. Remember to write that. So 2y, y dash. Then you do cross multiplying. V u dash plus u v dash. So the derivative is x by 2y y dash. You can start from the y squared by 1. So y squared by the 1 is y squared, and x by 2y y dash is 2xy y dash, and this is the final answer. Okay, guys, let's do this question now. Question number 1. We're still in question number 1. d by dx of ln x squared y cubed. I told you before, ln x squared y cubed, ln of multiplying ln of a times b is equal to ln a plus ln b. So before you start to differentiate, we have to simplify and split the ln into two parts. The first part, which is ln of x squared plus ln of y cubed. So we're supposed to do this. D by dx ln of x squared plus ln of y cubed. Good. Now you're supposed to move any power of the variable or the base of ln before the ln. This is one of the properties of the ln. So you're supposed to differentiate now. So we never start to differentiate. So it's 2 ln x plus 3 ln y. Now you can differentiate easily. Keep the 2 as it is, and derivative of ln x is 1 over x plus 3, and derivative of ln y is 1 over y, and remember to write y prime or y dash. Then the answer is 2 over x plus 3 y dash over y. If you want to simplify the answer first, so by the way, this is the answer that you have at the end of the textbook. But if you want to simplify it more, you need to make common denominators. So by multiplying denominators, you'll get xy, and then you do y by 2 is 2y, then x by 3, y dash is 3x y dash. Here's another example. X cosine y. Now we're supposed to use product rule. This is with trigonometry. So x is u and cosine y is v. Now let's differentiate each one of them individually. Yes, derivative of x. So u is x and v is cosine y. U dash is 1, v dash, v prime is negative sine y, y dash, y, because derivative of cosine is negative sine, so negative sine y, y dash. Then you do vy dash, vu dash, plus uv dash, or you can do the opposite. It's up to you, because at the end it's plus. So cosine y by the 1 is cosine y, then plus x by negative sine y is negative x sine y, y dash. Easily, you have to change the sign now. Positive by negative is negative, so cosine y minus sine y, y dash. Go again. D by dx of x squared e power of 2y. So again, we have to use product rule. U is x squared and v e power of 2y. Differentiation of u is 2x, and differentiation of v is derivative of the power times e itself. Guys, remember, you have to back to chapter 5 and make sure you understand and memorize all the rules of differentiation that you have there on chapter 5. Derivative of the power is 2 times e power of 2y without changing the power. And remember, because you differentiate respecting to x, you're supposed to multiply by u dash, y dash, or dy by dx, or y prime. Using product rule, so 2x e power of 2y plus 2x squared, x squared by 2 is 2x squared, e power of 2y, y dash. You can simplify it by taking 2x and e power of 2y as a common factor. See, 2 is repeated twice. X and x squared, you're supposed to take the least power, and e is repeated, so you have to keep the y dash as it is. So from the first term, only 1 is left from the first term, because basically in taking out the common factor, you need to divide. 2 dividing 2 is 1, x divided by x cancelled, e with the e cancelled. 2 divided 2, 1. X squared divided x, only 1x with y dash left from the second term. Question number 2, this question is asking to find dy by dx. Now we have to make dy by dx as the subject because you have an equation. Why we didn't do that before in the previous question? Because basically those questions was asking to differentiate terms, a specific term. Okay, so when you differentiate a specific term, so there is no two sides, it's not an equation. Well, now you have two sides, two equal sides. Now we can make y dash as a common factor or dy by dx as a subject because it's required to find that. Differentiation of x cubed, 3x squared minus, remember, xy squared. U is x, v is y squared. U dash is 1, v dash is 2y, y dash. Good. So keep the 2 outside. Then differentiate. This is the product of x and y squared. Y squared by the 1 is y squared plus x by 2 to xy, y dash, and then differentiation of 7x is only 7 equals to 0 because derivative is 0, derivative of the 0, or derivative of any constant without any variable is equal to 0. You need to expand the brackets. So keep 3x squared as it is minus 2y squared plus 4xy y dash plus 7 equals to 0. You couldn't multiply the 2 with the 7 because 7 is not included in the brackets. Now, as you see, it's only one term which has the y dash. Now, move all the terms to the other side and divide by the coefficient of y dash, which is 4xy. So I'll do that. I'll move 3x squared to the other side, negative 2y squared to the other side, and 7 to the other side. So you will have 4xy, y dash on the left side, 2y squared, minus 3x squared, minus 7. Then y dash is 2y squared, minus 3x squared, minus 7 over 4xy. And you got the derivative in terms of both x and y. Guys. Question number 2. We're still on the same question. It's required to find dy by dx. So we have to make dy by dx or y dash as a subject. So let's do normal differentiation. The derivative of 4x squared is 8x. Differentiation of 6y squared is 12y y dash. Then here you have to use product rule. So uv. U is x squared and v is y squared. U dash is 2x, v dash 2y, y dash. So let's do the same thing here. 3 times y squared by the 2x. So 2xy squared plus x squared by 2y y dash is 2x squared y y dash. I will just rewrite that again here. 8x plus 12y y dash equals to 3 2xy squared plus 2x squared y y dash. Expand the brackets. 8x plus 12y y dash is equal to 6x y squared plus 6x squared y y dash. Now you have to combine the like terms. So move this term to the left side and this term to the right side. And you have to take y dash as a common factor. So the common factor of y dash, you will have 12y, it's already in the side. And when you move that to the other side, you write it with a negative sign, negative 6x squared y equals 2. Keep the 6xy squared as it is, and you move the 8x to the other side, so minus 8x. Finally, y dash is this divided this. You can take a common factor, by the way. From 6 and 8, you can take a common factor. The common factor that you can take it is 2. X with the x, you can take x as a common factor, so only 3y squared minus 4 left. Now you do exactly the same thing with the other bracket. So 6 and 12, the common factor is 6, and you can take now y because y is repeated. Now 12 divided 6 is 2, and y is already outside. 6 dividing 6 is negative 1. X squared, and the y is outside, so it's 2 minus x squared. Now 6 is outside and y is outside, and only negative x squared is left. You can simplify it more. See, this is 1 and this is 3, and this is the final answer. This question, simply you do cross multiplying. That's it. X squared on the left side and then 4x plus 10y squared. Now we can differentiate. Derivative of x squared, we know that it's 2x, 4x is 4, and 10y squared is 20y, y dash. You have only y dash or y prime or dy by dx only in one term. So you can move 4 to the other side, 2x minus 4 equals 20y, y dash. Then y dash is 2x minus 4 over 20y, or you can take a common factor from the numerator, which is 2. So x minus 2 left, and over 20y, 1 and 10, because 2 over 20 is equal to 1 over 10. So the final answer could be x minus 2 over 10y. Guys, let's do question number 3. Find dy by dx. So this question is exactly the same thing as we did in the previous question. 4e power of xy minus 3x e power of y. So once you see any term which has different variables x and y, so we're supposed to make directly product rule in case of multiplying, as you have now, or quotient if we have divide. So this is u and this is v, or you can consider the whole thing as u, this is u, and this is v. So u is 4ex, v is y, so u dash is same thing 4ex, and v dash is y dash. And for the same thing, u is 3x, v e power of y, and then u dash is 3v dash, because you differentiate respecting to y, it's e power of y, y dash. Then cross multiplying, remember to do this, cross multiplying. So y v by u dash, or u dash v, then u v dash, v u dash minus u v dash. So the derivative is 4ex y dash minus plus 4exy minus, open the bracket, vu dash 3 e power of y plus 3x e power of y, y dash equals to 0. Now we need to expand the brackets. We have two terms having y dash. So 4exy dash plus 4exy minus 3 e power of y minus 3x e power of y, y dash equals to 0. I'll keep these two terms here and move the rest. So take y dash from these two terms, you have 4ex left, minus 3x e power of y equals to, if you move these two terms to the other side, so 3 e power of y minus 4 e power of xy. No common factor, so directly y dash is equal to this divided this. No common factor at all. 4exy dividing by 4ex minus 3x e power of y. This is the final answer. This question, u, v, product rule. U is 2 sine 2x, v is cosine 3y. U dash is 4, because derivative of 2x is 2, so 2 times 2, 4, and then you change sign to what? Cosine of 2x. V dash, derivative of cosine is negative, and differentiation of 3y is 3 sine of 3y. Vu dash, so Vu dash plus uv dash. So let's start from here. 4 cosine 2x cosine 3y minus, it's supposed to be plus, but because you have a negative sign, so negative 6 sine 2 times 3, 6 sine 2x sine 3y equals to 0, because derivative of any constant is equal to 0. Remember here, once you differentiate, you have to write y dash, because you differentiate respecting to x. So I'll add the y dash here. Now you can move this to the other side. You just move this to the other side. It's up to you. I will move this. 4 cosine 2x cosine 3y equals to 6 sine 2x sine 3y y dash. You need the y dash as a subject, so you need to divide this by this, not the opposite. Y dash is 4 cosine 2x cosine 3y dividing by 6 sine 2x sine of 3y equals to 4 over 6 in the simplest form is 2 over 3. Cosine over sine is not equal to tan. Sine over cosine is equal to tan. Cosine over sine is equal to what? Cot of 2x. And cosine over sine again, cot of 3y. And this is the final answer. Same thing here. 4xy minus x ln y cubed. So again, 4x u v u v. But we can do something here. We can move the 3 before the ln, or you can write it with the x. So 4xy minus 3x ln y equals to 8. Now start to differentiate. I know it's supposed to be u and v, but you can do it by yourself. Now differentiation of 4x, 4, and keep the y, plus 4x and differentiation of y is y dash, minus, open the bracket, 3x is 3 ln y, plus 3x and differentiation of ln y is 1 over y, y dash equals to 0. Because differentiation of 8 is 0. It's a constant. Now two terms having y dash. Expand the brackets for y, 4xy dash minus 3 ln y, plus 3x times 1 is 3x over y, y dash equals to 0. Move these two terms to the other side and take y dash as a common factor. So y dash common factor. Now 4x plus 3x over y equals to 3 ln y minus 4y. Final answer y dash, this divided this. 3 ln y minus 4y dividing 4x plus 3x over y. By the way, you can continue the answer by making a common denominator of the denominator part. But simply, this is the final answer. This question, now question number 4, is asking for the gradient. You know that gradient has only 2 steps. So the first step is to differentiate the function. This is step number 1. And step number 2 is to replace x. This is that we did before in chapter 5, or with explicit differentiation or explicit function. Now, but with the implicit, we need to use both if the x and y exist on the function after you differentiate it. So let's differentiate first. Differentiation of x squared is 2x. Differentiation of 3xy using product rule, differentiation of 3x is 3y plus 3xy dash plus differentiation of 2y squared is 4y y dash. Remember 15, you don't have to write it again. You couldn't write it again, so it's equal to 0. X and y. Directly replace x and y without rearranging the derivative. Directly. So 2 times 1 plus 3 times 2 plus 3 times 1 y dash plus 4 times 2 y dash. Then start to evaluate. 2 plus 6 is equal to 8. Then 3 y dash plus 8 y dash equals to 0. Keep the 8 as it is. 3 plus 8 is equal to 11 y dash. Move the 8 to the other side, so y dash is negative 8 over 11. So what we get now is the value of the gradient, negative 8 over 11. Question number 4, we're still in the same idea. Find the gradient. So x 0 and y is 2. Using product rule, u and v, differentiation of ex is same thing, e, power of x, keep the y, plus keep e power of x and differentiation of y is y dash. X squared 2xy. If you differentiate only the x squared, then you keep the x squared and differentiate y. So derivative of y is y dash and the constant is 0. Directly replace e power of 0 times 2 plus e power of 0 y dash plus 2 by 0 by 2. So directly this term is cancelled because it's multiplying 0. And 0 squared y dash equals to 0. Again, this term is cancelled. Any number to the power, any base to the power of 0 is equal to 1. So it's 2 plus 1 times y dash is y dash. Move the 2 to the other side. So y dash is equal to negative 2, or the gradient is negative 2. Just to remind you guys, this part, this gradient, is the gradient of two things. So it's gradient of the curve or gradient of the tangent. But if you want to find the normal, remember, we have to flip and change the sign. That's it. Now, question number 10, which is based on what we did in question 4. Find the equation of the tangent. So it's supposed to be only one equation of tangent. Tangent T. X and Y. Remember to use UV, product rule. Differentiation of x is 1, ln y. 1 times ln y is ln y. Then keep the x and differentiation of ln y is 1 over y, y dash. Again, y, differentiation of y, y dash ln x, plus keep y and differentiation of ln x is 1 over x. Differentiation of the constant is equal to 0. Now replace the values. Ln of e, and remember that e is e power of 1, plus 1 times 1 over e y dash, plus y dash ln of 1. Remember ln 1 is equal to 0. And y, e times 1 over 1, which is equal to 0. Now ln e cancelled, and you have only 1 left. This is e, so 1 plus 1 over e y dash plus e equals to 0. You need to move these two terms to the other side, and you keep the y dash as it is. 1 over e y dash equals to negative 1 plus e, or negative 1 minus e. It's the same thing. Just you do cross multiplying, so y dash is equal to negative e times 1 plus e. This is the gradient of the tangent. You need to use that directly on the equation of tangent. So you use y minus y1 equals mx minus x1. You can do it by yourself. Guys. Question number 11. Find the equations of the tangent and normal to the curve. Sine x, sine y equals to root of 3 over 4. So we have to use product rule. U is sine x, v is sine y. U dash is cosine x, and v dash is cosine y, y dash. Using product rule, vu dash, so cosine x sine y plus sine x cosine y, y dash equals to what? 0. Because root of 3 over 4 is a constant, and derivative of any constant is equal to 0. Now we have to replace the values. Cosine of pi over 3, sine of pi over 6, plus sine of pi over 3, cosine of pi over 6 y dash equals to 0. Cosine pi over 3, which is cosine 60, is equal to half, and sine of 30 is half. Sine of 60 is equal to root of 3 over 2, and cosine of 30 is the same thing. You can use the calculator to find these values. Quarter plus 3 over 4, y dash equals to 0. You move one of them to the other side. Then 3 over 4, y dash is negative quarter. 4 cancelled 4, then which means the gradient is negative 1 over 3. This is the gradient of the tangent, and gradient of the normal, of course, is what? 3. Here is the equation of the tangent, and here is the equation of the normal. Equation of the tangent is y minus pi over 6 equals the gradient negative 1 over 3 x minus pi over 3. Then you move that to the other side. Y equals to negative 1 over 3x plus pi over 9 plus pi over 6 in a simplest form. Negative 1 over 3x plus the denominator is common denominator is 18. So 9 becomes 18 by multiplying, but you can use the calculator. It's 2 and this is 3, so it's by multiplying by 3, so 3 pi, it's 5 pi over 18. Equation of normal. I know on the textbook you'll find that as over 6, but you need to multiply the whole equation by 3 to get rid of the 3 from the denominator, or you can multiply the whole equation by 18. It's up to you. Now, equation of normal is y minus pi over 6 gradient 3x minus pi over 3. You need to expand the brackets and move that to the other side. 3x minus pi plus pi over 6. And then y equals to 3x plus 5. 6 by negative 1 is negative 5. It's negative 5 pi over 6. Question 13. If x squared plus 3xy minus y squared is equal to 3, find the first derivative and the second derivative at this point 1 and 1, x and y. So which means it's required to find the first derivative and the second derivative at the given point. Let's differentiate first using get the first derivative. To get the first derivative, 2x plus, remember, product rule, 3x is 3 times y, plus 3xy dash minus 2y y dash equals to 0. Now replace directly the 1. This is the first derivative. Remember, this step is for the first derivative. Replace the x and the y. 2 times 1, 3 times 1, 3 times 1 y dash minus 2 times 1 y dash equals to 0. 2 plus 3, 5. 3 minus 2 is 1 y dash equals to 0. You move 5 to the other side, so y dash is negative 5, or the gradient of the curve, or the gradient of the tangent. Now it's required to find the second derivative as well, so we have to differentiate each term individually. Start from the first derivative. 2x is 2. 3y is 3y dash. Product rule. Plus 3x is 3y dash. Plus 3x and differentiation of y dash is y double dash. This is the second derivative. Do the same thing. Minus, open the bracket. 2y is 2y dash. And you have already y dash. Plus, keep the 2y and differentiate y dash, which is y double dash equals to 0. Replace y dash that you got before and the x and y if you have it. 2 plus 3 times negative 5 plus 3 times negative 5 plus 3 times 1 y double dash minus 2 times negative 5 squared. Remember, y dash times y dash is y dash squared. Minus, because you expand the brackets, 2 times 1 y double dash equal to 0. 2 minus 15 minus 15, 3y double dash minus 50, because negative 5 squared is 25 times 2 is 50, minus 2y double dash equal to 0. By combining these two terms, you'll get the y double dash. 2 negative 15 is negative 30. Negative 30 and negative 8 is negative 80. Negative 80 plus 2 is negative 78. Negative 80 plus 2 is negative 78 equal to 0. You just move that to the other side, so y double dash is positive 78. This is the value of the second derivative at the given point. Question 16. Find and classify. Classify means to state the type. It's the same thing as state the nature, determine the nature, determine the type, classify. So classify means you have to give the type of course, the stationary point, as you see. Classify and find the stationary point on each curve. So basically in this question you have three equations. We're going to do only one of them, and you can do the rest by yourself. X squared is 2x, y squared is 2y, y dash, product rule, 6xy, 6x by y dash, plus 6 by y, because derivative of 6x is 6y, and you keep the 6x and you differentiate the y, which is y dash. Negative 90 is cancelled. Stationary points means y dash equal to 0. So all the terms which having y dash cancelled. Now 2x equals to 6y. Now we can write x in terms of y or y in terms of x. It's up to you. For myself, I prefer to make x here in this question to be in terms of y, because you need to divide both sides by 2. So x is equal to 3y. Now we can use the x directly on the equation to find the value of y, or the values. It's based on number of points that you're going to find. Yes, on the equation of the curve, x squared is 3y power of 2 minus y squared, 6 by 3y, y minus 90. It's 9y squared. It's not 6y squared. It's not 3y squared. It's 9, because you have to give power of 2 to both of them. Minus y squared equals to 18y squared minus 90. By moving that to the other side, 9 minus 1 is equal to 8. 8 minus 18 is negative 10y squared equals to negative 90. Then y squared is equal to 9, because 90 divided 10 is 9. By taking the square root of both sides, you'll find two values of y positive and negative 3. Once you got the values of y, you can find the x now. So we have to get the x by using positive 3, so 3 times 3, which is 9, and the other x value, 3 by negative 3, is negative 9. So the points, or the stationary points, are 9 and 3, negative 9 and 3. Now we have to state the type. We couldn't use here the number line at all. You know why? Because you have two variables, x and y, so we couldn't state which one. Maybe you'll find them of the same type, maybe you'll find them different, but the best way to state the type on the implicit functions is to use the second derivative. So directly from this step, the step is the first derivative. We have to differentiate it one more time. So derivative of 2x to find y double dash. Remember, this was y dash. 2x is 2. Remember to use the product rule. So it's 2y dash, plus 2y, y double dash. Again, use product rule here. 6y dash plus 6x, y double dash plus 6y dash. We know that from the first thing on the question, stationary points, y dash, any term has y dash is cancelled because it's 0. Now you have to replace once the x and once the y, or sorry, once the first point and once the other point. I'll use 9 and 3 first by replacing 9 and 3. So 2 minus, remember, negative 2 by the y, y double dash, equals to 6 by 9, y double dash. By moving that to the other side, it's 2. This term goes to the other side with a positive sign. So you have, this is 54. 54 plus 6 is equal to 60, y double dash. At the end, y double dash has a positive value. So what's the type here? It's a minimum stationary point. Now let's continue the previous question, question 16. So remember we did 9 and 3. Let's do now negative 9 and negative 3. Now second derivative was 2 minus 2y double dash equals to 6xy double dash. So 2 minus 2 by negative 3 y double dash equals to 6 by negative 9 y double dash. Move that to the other side. So 2 equals, this is negative 54, and this is plus 6. So it goes to the other side as a negative sign. So positive, it goes, sorry, with the negative sign. So negative 60 y double dash. Now y double dash has a negative sign. So what is the type? It's a maximum stationary point. Last question. Sorry. Question 18. A curve C has the equation of y equals to x minus 2y cubed. Yes. Let's differentiate first. It's required to find the first derivative in terms of y. Y is y dash, x is 1, and 2y cubed is 6y squared y dash. You have to make y dash as a subject, so you have to combine the like terms. I move that to the other side, and you take y dash as a common factor. The coefficient of y dash here is 1 plus 6y squared, because we took y dash as a common factor, equals to 1. Then first derivative is 1 dividing 1 plus 6y squared. This is the first derivative. Second question, it's required to show that the second derivative is equal to this. So you can use quotient rule because it's dividing, or you can use chain rule. For myself, I prefer to use the chain rule better than using the quotient rule, because that will take a long time. See, y dash in a simplest form is 1 plus 6y squared power of negative 1. Why? Because the power of the denominator is 1. It's not power of 2. That power of 2 is only for the y. It's power of negative 1. Now second derivative, move the negative 1 before. So negative 1 plus 6y squared power of negative 2. Multiplying by a derivative of the expression which is inside, it's 12y y dash. Now by rearranging the terms, negative 12y y dash over 1 plus 6y squared all to the power of 2. But see, the final answer has to take power of 3, and there is no y dash. But remember, your y dash was 1 over 1 plus 6y squared. So we're going to replace that. Negative 12y times 1 over 1 plus 6y squared over 1 plus 6y squared to the power of 2. Denominator of numerator is denominator of the whole fraction. So it goes down. Then you have negative 12y all over 1 plus 6y squared all to the power of 3, which is proved completely. Thank you, and see you on the next topic.